Hello, everyone. So this is section 6.3, which is about integration by parts. All right. So in this section, let's say, okay, let's say if we want to integrate something like this. Okay. So for something like this, using integration by parts, well, in this case, well, we don't have to use integration by parts. We can just simply use the technique we learned so far, right? So we can simply say x squared over 2 plus c, right? And these kind of integration. But let's say if we are trying to integrate x times natural log of x dx. Okay, so far we have learned substitution, right? Yeah, we have learned substitution, integration by substitution, but it looks like I cannot use substitution method here. The reason for that is, well, even if I assume this u, this just x as u, I don't think that would work, as I have x here. If this was x squared, then maybe this would have worked, but here we have x, so it looks like it's not going to work here. So in this kind of case, we need to use the integration by parts method. So integration by part says that, okay, so if we have, let's say, integration of u dv, then I can also say that this is equals to, this is v u dv, all right? So u times v minus integration of v du. Okay, so that means I need to change change this integration to this form. Okay, so that means from this integration, well, I can directly now, well, I have u here, right? So let's just assume that x is u, or u is x. Okay, or let's do this instead of assuming. So what we can do here is, well, this is x times natural log of x times dx, right? So in this case, we can either assume u is natural log of x, and now the remaining terms we have is x and dx. So those remaining terms we can assume that as dv. Oops, dx. Okay, so whenever you have a natural log in your integration and you're trying to use integration by parts, then it's always safe or easy if you just assume natural log terms as u. Okay, so this is just a technique. Well, you don't have to apply this, but it will make the problem easy. Okay, so here, once we do that, okay, so assume this thing u and rest of the term dv, right? The reason I'm doing this is I'm trying to change this to this form. Okay, so now this is equals to this thing. So now let's find, well, we have u, let's find v, and let us find du as well, because we don't know du as well, right? We don't know du. We have u, but we don't know du. We have dv, but we don't have v, right? So let's find those two. We can find du from this, right? So I can just take du, or I can just take the derivative of this with respect to x, right? The reason I'm having x here is because this equation is in terms of x. So du over dx, or when I take the derivative of natural log of x, it is 1 over x. right? Okay, so from here, let's do this. Let's just separate these two by a line. Okay. So now to get the value of this du, or the equation of du, just multiply this dx on both sides. So du is equals to 1 over x dx. Okay, so we got the equation of du, right? Now we need v. Okay, so what we can do with this equation here is to get the value of v, I can just integrate both sides, or put integration sign both sides. All right, and here we can just write 1, because 1 times dv is still dv. 1 doesn't make difference, right? Now on left hand side, when I take the integration of 1, what do we get? So let's say when we take the integration of some constant number, let's just say 2 dx, we did this, right? So if we just have a number, then this is just 2x, right? So similarly, and the reason I get x here is I have dx here, because I'm integrating in terms of x. That's why I get x here. Now here I'm integrating in terms of v. So I have 1 here, I'm integrating in terms of v, so that's why I get 1 times v, or just v. Or 1 times v will still get v, right? So yeah, so I can just write v. Now here I can integrate x dx, so here I'll just get x to the power 1 plus 1, which is 2, over 1 plus 1 is still 2. And plus c, but right now let's not write plus c, because on the final answer we can just, if you just write plus c on the final answer, that should be okay, but let's just not write plus c right now. Let's just leave it like this at the moment, okay? Now, okay, now let's just take the integration. So I have u dv, which is these things, right? U dv are this actual original equation, right? Is equals to uv. So u times v is natural log of x times x squared over 2 minus integration of v is x squared over 2, and the du is 1 over x dx, right? So here we don't have to do anything with this, right? So x squared natural log of x over 2 minus, here I can cancel x squared and x, so here I'll get 1 over x. This 2, I can bring this 2 out, right? And dx. So now after this, now I can integrate this 1 over sorry, oh, I did a mistake here. Sorry, x squared over x is just x, right? My mistake. This is just x. Okay. So after this, when I integrate just x, then, well, if I can just rewrite this here again, x squared natural log of x over 2 minus 1 over 2. Integration of x is x squared over 2. Now I can write c. Now the final answer, we can write c. And again, because on the exam, I saw that some of you guys wrote c even if there was the interval. So if there is interval, then you don't have to write c. If there is no interval, then yes, you have to write c. Okay, so just be clear with that. And well, after this here, it looks like, well, I can just multiply these 2 and 2, right? So x, I can just say x over 4, x squared over 4. So this should be the final answer. Okay, so here the main idea is this. So just remember this as a formula. Okay, so this is a formula of integration by parts. Okay. So this is number one. Let's do number two, or another problem. Okay, so another one is integrate x squared e to the power 2x dx. Okay, so now when we have e on the equations, like I said here, when you have a natural log, then it is safe, it is easy if you just assume natural log terms as u. Okay, now when I have e here, then let's take another terms as u. So let's take u as x squared. Okay, and then the rest of the term, because again I'm trying to convert this to u dv is equals to uv minus v du, right? So yeah, again, remember this. Okay, remember this, don't be confused. If you just write this 4 or 5 times to memorize this. Well, and this one obviously you can obviously check because it's an open book, so you can check it. But if it was in class, then you should have remembered. But anyway, okay, so here first u is x squared. I said that. Now that's u, and the rest of the terms is dv, right? Okay, now after that I have u, I don't have v, I don't have du as well. So I can get those two, right? I don't know, I need to find v, I need to find du. So from here I can get du. So du is equals to 2x, or du over dx is equals to 2x, right? Because I'm taking the derivative. And then after that, multiply both sides by dx. So du is equals to 2x dx. And similarly from here, I can just integrate both sides. There's one here. So on left hand side here, the integration of one is just v. The reason I get v here is I have dv here. If there is du here, then it would have been u. But here we have v, so that's why I have v. Okay, now integration of e to the power 2x is, okay, so again, you can also take this as a formula, because I think we have done this on chapter 5 or something like that. But let's say if you are taking the integration of, or yeah, I think we've done this in chapter 5, but I don't remember. Anyway, I can just tell you again. Let's say if we have integration of e to the power a times x dx, so a is some number, then in this case, I can say the integration is 1 over this number, 1 over a times e to the power this whole thing, a times x plus c. Okay, so basically I can get this formula using substitution method. Yeah, I can get this using substitution method. All right, so that's a trick. But anyway, if you just remember this formula, then I can just now directly write from this one. In this case, a is 2. So that means I'll get 1 over 2 is equal, or 1 over 2 times e to the power 2x plus c, but let's not write plus c at the moment, okay? I can write plus c in the final answer. Okay, so now it looks like I have everything. So here du dv are exactly this thing, right? This whole thing is equals to, so du dv, which is this, this is equals to uv, uv is x squared e to the power 2x over 2 minus v is this whole thing, right? 1 over 2 e to the power 2x, and du is this thing, right? 2x dx. Okay. So now I can just cancel this 2 and 2. So basically this is x square e to the power 2x over 2 minus integration of x e to the power 2x dx. Well, I was trying to take the integration of this, right? And here I got a term minus one more integration, right? So how do I get rid of this integration now? So now to get rid of this integration, I have to use another integration by parts method, just like I did here. So I have to use another integration by part method for just for this. Just name this a star. Okay. So, and also let's name this whole equation, this whole thing as equation 1. Okay. So let's just integrate, or let's just find the integration of just this star, just this thing. Okay. So just for this thing, I can use the same method. So again, I can now assume u is x and dv are rest of these terms. So e to the power 2x dx. So when I in here, when I take the derivative, so it will be du over dx is equals to the derivative of x is just 1, right? And then just multiply both sides by dx, so du is equals to dx. All right, so I got the value of du. Now dv here, so again I can integrate or take the integration sign on both sides. So here it's 1, right? So the integration of 1 is, well, here we have dv, so it's just v is equals to the integration of this e to the power 2x is, again using this formula, it will be 1 over 2 e to the power 2x plus c. Again, I don't have to write plus c. Okay, so now let's see if we get rid of uh, the integration here. So now just remember, we are taking the integration of this star sign, right? For this, we are just taking the integration of this star. Okay, now let me do this on another page. So, oops, sorry. Okay, so first, this is only for a star. So for a star, u dv is equals to uv. So uv, so u and v is x e to the power 2x over 2 minus v du is minus integration v du is v is this and du is dx, right? So v du is 1 over 2 e to the power 2x and du is dx, right? So now so 1 over 2, I can just bring that out and just take the integration of e to the power 2x, right? That's again integration of something like this is 1 over a, right? So again, I can only use the integration for this, so I will get 1 over 2 and other 2, right? 1 over 2 and e to the power 2x plus c, right? So here, the 1 over 2 times 1 over 2 is 1 over 4. Okay, so Just remember that now this is, like I said, this is only for star, right? Only for star from this equation 1, because our final answer, well, whatever we got here, we should substitute this, because this is only for a star. So I need to substitute this back to this equation 1, right? So let's substitute this here. So this will stay. Okay, so our final answer, using equation 1, right? So equation 1 says that it's x square e to the power 2x over 2 minus, right? There is a minus here, so we need to include this minus as well. So minus and this thing, right? So these are the star, right? This is a star. So the star, well, I need to make sure you substitute this minus to all of these, okay? But okay, substitute this here, so it will be x e to the power 2x over 2 minus minus plus 1 over 4 e to the power 2x minus plus, but since this is a constant, right? So this is a constant. We don't know exactly what this is, what c is. We don't know if c is a positive number or negative number. So in this case, again, I can just say c. Okay. Well, if you want, you don't have to write c here. Like I said, you can only write c the final answer. So c just a constant. Okay, so that's why I said plus here. Even if you say minus c, that wouldn't make difference. You can still say minus c, but yeah, normally book writes plus, so we're just following the book, how the book is doing. So okay, so this is the final answer. Okay, so this is number 2. So here we used integration by parts 2 times, right? Okay, so let me do another one. Okay, so here we are taking the integration of natural log of x. All right, so we are taking the integration of natural log of x. Don't be confused. Okay, so when you take the derivative of natural log of x, it is 1 over x, right? Derivative, we write it like this. So when I take the derivative of natural log of x, it is 1 over x. When I integrate 1 over x, we go the opposite way. So we get natural log of x, right? But what about when you integrating natural log of x? So for this, we don't have any formula. So we need to actually solve this, okay? So using integration by parts, right? So it has to be, first we need to change this to u dv, right? I have to change this integration to this form. And once I change this to this form, this will be equals to uv minus v du, right? So first, okay, u here, I can assume this natural log as u. And now only remaining terms we have is dx, right? So I can assume that dx as dv, so dv is equals to dx, right? Okay, so that means I have du, dv, we are still missing v and du, right? So I can get that. So first I can take the derivative of u in terms of x, so du over dx is equals to, now derivative of natural log of x is 1 over x, right? That's what I said here. Now multiply dx on both sides, so 1 over x dx. So that means I got the value of du. Now I need the value of dv, right? So to get the value of dv, again, I can integrate, put the integration sign on both sides. Let me just make it clear. Okay, so here, dx, something like this, right? Okay, so here again, we can write 1 here, we can write 1 here. So if I integrate 1 with respect to v, then I get v, or 1 times v, which is just v. Now similarly for this one, when I integrate this with respect to x, I want to integrate 1 with respect to x, then it is 1 times x, which is just x. Okay, so that means I got the value of v as well. V is equals to x. Okay, now let's use this. So using that, v du is this, right? So v du is equals to uv. So uv is x natural log of x minus integration of v is x and du is dx. Okay, now x natural log of x. So the integration of x is oops, I did a mistake, sorry. So du is, sorry, here. So v is x and du is 1 over, I missed this, 1 over x dx, right? Now, after this, I can just cancel these to x and x, so I get 1 times dx. Right now, after this, I can take the integration of this. So x natural log of x minus, so the integration of 1 is just x dx. And the final answer makes you write plus c. All right. So if you don't write this plus c, you will lose points. Okay, so you have to write this plus c at least in the final answer. Okay. Okay, so just for practice, well, this is not a quiz problem. Okay, this is only for you to practice. Okay, I'm pretty sure that you will do the similar problem and the Pearson homework as well. But still, I just wanted to give you for you to practice for the exam. Okay, so natural log of x over square root of x dx. X times e to the power x plus 1 dx, number 3, integration of x to the power of 3 e to the power x dx. Okay, like I said, again, this is not a quiz problem. Practice these problems, all right? So it will be easy in the exam if you practice these kind of problems. Okay, now this, okay, so far I covered section 6.3, right? So let me cover 6.4 as well and the same lecture. Okay, so this is supposed to be 6.3 is supposed to be Thursday lecture, right? Now I'll be covering 6.4 as well for this Thursday lecture. So 6.4 was actually supposed to be covered for Friday, but since I'm covering this on Thursday lecture, so Friday there won't be any lecture. Okay, so maybe Friday morning before the actual class time, which is actually 8:40. So before this, I will send you guys the review, exam 5 review. So let me cover 6.4 first. Okay, so 6.4. Okay, and this section 6.4, I will just give you a lecture of this section. I'm not going to ask you any problem on exam 5 from this section. Okay, so I'm not going to ask you anything. The only point, the only reason for covering this section is that I want to just introduce some terms. Just in case if you take some higher level math course, you will probably see these kind of terms later on. So I just want to introduce those terms. That's it. Okay, so I'm not going to really go into this section. So that means I'm also not going to assign any homework or any Pearson homework for this section. Okay, so but I might assign quiz. Okay, so make sure you watch the rest of the video as well. I might assign some quiz. So just watch the whole videos to see whether I assign or not. So this section is basically about trapezoidal rule, and another one is Simpson rules. But let me first talk about this. I'll just give you a brief idea of what this means. I'm not really going to go into anything. Okay, so here, let's say if we have a curve, something like this, and the interval we're considering is from A to B. Okay, so and let's say this is f of x. So when I integrate this f of x from A to B, I get the area, right? I get the area of these things. But using the trapezoid rule, I can also take the area of this if I, let's say, divide this interval into small sub intervals. So let's say really small one. Let's say this, 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 this. And let's name this point x naught or x0, x1. All right, so it's just going to go on like that. All right, so let's say if I take, okay, let's say if I take the area of this. So if you see the bigger picture of this thing I just stated, so if you see the bigger picture of this, it's going to look something like this. Oops. Yeah, just assume this as a straight line. Sorry, yeah. Okay, so this shape is called trapezoid. Trapezoid. That's why this is called trapezoidal rules. Okay, so now if I take the area of all of these and just sum this all, or take the sum of the area of all of these, then I will get the area of this whole thing between this interval, right? So that's what the idea is. And I'll just write probably the equation of the trapezoid. So the area of this whole thing will be t to the t base n of, let's say, f. It would start from here. So f x naught. One thing, actually x naught, or instead of writing x naught, or instead of writing a, I can write this as x naught. This is x1, this is x1. Okay, and it's just going to go on like that. Okay, so, and this final point B is xn. Okay, so now using the trapezoidal rule, there is equation which is f x naught plus 2 f x1 plus 2f x2 plus 2 times f xn and delta x over 2. So this delta is b minus a over n. So B minus A are basically, this is with this line, the biggest line, this here is B, this line is A. Okay. And N is, let me check. Okay, so the N is this final, oh, sorry, this is not A. So the A is, sorry, I forgot, sorry, we know that value of A, sorry. Oops, my bad, sorry. A will we have here, right? So A is this starting point, and B is this point, okay? And f of x naught, f of x1. So for this one, for this point will be f of x naught point, and this point will be f of x1. Okay, this is trapezoid rule. We can even say trapezoid rules. And now second one is Simpson's. So on this rule, there is another equation. So again, this for Simpson rules, the concept is similar to what I explained here. Okay, now on this one, the equation is something similar, but not exactly same. This is x1 plus 2 f x2, and again now 4 x3 and it will be f x 2n. The reason I have 2n here in the final terms is this we have 2 here, okay, and times delta x over 3. So this is a formula, okay. Like I said, I'm not really going to go into this thing on this chapter. Just wanted to give you the idea of this. That's the whole reason of covering this section. Okay, yeah, it looks like that's it. So that's it for this semester, I guess. I won't have any new thing to cover. Maybe I will review a few things for the final exam, and maybe I'll upload a review video for the final exam. But at least before final, you have one more exam, right? Exam 5. So exam 5, it looks like for exam 5, I have only 2 sections, right? 6.1, which I divided this section into 2 lecture, right? And the section 6.3, right? I skipped 6.2, right? So 6.1 and 6.3, all right? So there are only 2 sections. So make sure you understand everything from this section, and the exam is this coming Monday. Right, so yeah, so if you have any questions, anything, you can always email me. We can set up a time to meet in the Zoom, or yeah, since we're almost done with the semester. So yeah, make sure you email me if you have any questions so we can just talk through the Zoom. Okay, all right, thank you. And I hope everyone will do okay. All right, I'll see you around sometimes maybe. Thank you.